So our last set of notes in Module 1, it combines 1.6 and 1.7. And we're going to be talking mostly about absolute value equations. And then we're going to talk a little bit about inverse and compound. Or maybe equally about all three. We'll see. So keep in mind that for an absolute value equation, absolute value has two solutions. Meaning, if I were to ask you what is the absolute value of -17, you would say 17. What is the absolute value of 17? You would also say 17. So we need to keep that in mind when we're solving these. My first thing is always going to be to isolate the absolute value. And if you're ever unsure about what to do to isolate it, put your finger over it, pretend this is an x. If this was 5 minus 7x, the first thing you would do would be to subtract this 5. Okay, and then again, if this were an x, the next thing you would do would be to divide by -7. Now, a side note that if at some point you wind up with an absolute value equals a negative, you can't solve that. So if I had like the absolute value of x plus 1 equals -3, I would say there are no solutions. I can't solve that. Because absolute value always gives me a positive output. Okay. So here, what I need to keep in mind is that the absolute value of 4t, that when I take the absolute value, that means that 4t, either 4t could equal 8, 4t plus 1, excuse me, could equal 8, because the absolute value of 8 is 8. Or 4t plus 1 could equal -8, because the absolute value of -8 is also 8. So if 4t plus 1 wound up being -8, I would take the absolute value of -8 and get +8. So for these, once your absolute value is isolated, you're going to set up two equations, one with this equals whatever number you have here, and one with this equals the negative of whatever number you have here. And then you're just going to solve them both. So subtract the 1, divide by the 4. Subtract the 1, divide by the 4. And I think that Moore just wants you to separate them with a comma. So -9/4, comma 7/4. Okay. Now, with every type of function, regardless of what type of function it is, every function, we do the same thing here. For the x-intercepts, we set y equal to 0, and for the y-intercepts, we set x equal to 0. So for the v-intercept, we're going to make k of v 0. And for the k of v-intercept, we're going to make v 0. Okay? So for the v-intercept, we say that k of v is 0, and we solve. And then we add the 2. Oops. And then we divide by the 2. Okay, now again, here, if v plus 4 equals the absolute value of v plus 4 equals 1, then either v plus 4 could be 1 or v plus 4 could be -1. Because the absolute value of 1 is 1 and the absolute value of -1 is 1. Subtract the 5. Subtract the 4. What am I doing? Hello. Like just making stuff up. Be -3. Subtract the 4. And usually Moore wants intercepts as points. So usually if they ask you for intercepts, they're going to want you to write these as points. Okay. I have found that since questions are often written by different people, Sometimes the output is expected differently, so this might just want -5 and -3, but 90% of the time, if it asks for intercepts, it wants points. Okay, so for the K of v-intercept, we make v0. So this would be K of v equals 2 absolute value of 0 plus 4 minus 2. 0 plus 4 is 4. The absolute value of 4 is 4. 8. So then this would be 0, 6. Okay. And then because of the nature of absolute values, when we see an absolute value inequality, we have to deal with them specially. So an absolute value inequality that has a less than becomes an and an absolute value inequality that has a greater than becomes an or. And I'm not even going to pretend that I remember those. I'm literally sitting here and I kept this up on the screen so that I remembered. So, I mean, the nice thing about us being in this environment is that you have the opportunity to make sure that you're keeping things near you when you're taking assessments, when you're taking quizzes. So again, make a note of this somewhere for yourself. If you see a less than, you make an and. If you see a greater than, you make an or. So an and inequality is one of the inequalities that's a compound where it's 3 terms in the same inequality. So for example, what I'm going to do to this is I'm going to make it -3 is less than 2v plus 8 is less than +3. So you take whatever number you have here, you make it negative, and you flip it over here onto the other side. And then when we solve these inequalities, we just do whatever we do to the middle to isolate the v, we're going to do to both the left and the right as well. So if I subtract 8, I subtract 8 on both the left and the right. -3 minus 8 is -11. 3 minus 8 is -5. And then we divide everything by 2. So -11 divided by 2 is, we could just leave it like that. We could just leave it like that. Now, a note that if this has an or equal to, then so should this. So whatever this is, you're just going to put the exact same sign over here. So since this didn't have an or equal to, mine didn't have an or equal to. But if there was an or equal to, that would have carried. I hope that makes sense. And now in interval notation, then this would be parenthesis -11/2, -5/2. Also with parentheses, because those are less thans, they don't have the or equal to. Remember, if they do have the or equal to, then you use brackets. Okay. And then the or inequalities. Oops. If I write this, you're going to write 2 separate inequalities, and you're going to say, okay, the first one is you're going to copy exactly what you have there. Or you're going to flip this sign and you're going to change the sign on your number, or it is less than -31. Okay, and then you're just going to solve the left by itself, and then when you're done with that, you're going to solve the right by itself. So here, again, if you're not sure, if we cover up this absolute value and treat it like an x, the first thing I would do would be to subtract the 7. The next thing I would do would be to divide the 8. Oop. So once I do that, those absolute value bars, they become parentheses. Oh, no, wait, I screwed this up. Oh, I was supposed to isolate the absolute value before I did that. It is Saturday morning, guys. Let me fix that. Okay. That was really weird of me. So this is a absolute value of 6v plus 5 plus 7 is greater than 31. The first thing I have to do is isolate the absolute value. I don't know where my head was at right now. I apologize. Isolate the absolute value, subtract the 7. Divided by the 8. Now we split it. So now we say either 6v plus 5 is greater than 3 or 6v plus 5 is less than negative 3. Oof, I'm sorry. Although I got halfway through that and was like, wow, I did this whole thing wrong. At least I realized it. Now you're going to solve the left side. Negative 2. 2 divided by 6 would reduce to negative 1/3. And then you're going to solve the right side. That would be negative 4/3. And so then in interval notation, always look at the less than first if you have an or like this. So this would be negative infinity to negative 4/3. And then union negative 1/3 to infinity. I'm sorry about that. Okay, so the next thing that we're going to talk about are inverses and composite functions. So functions that are inverses are functions that are opposites or they undo one another. So a quick example of inverse functions is if I have 2x, the inverse of that would be 1/2 x. Or if I have x plus 2, the inverse of that would be x minus 2. Okay? So if I have a point on f of x, xy, then I have a point on its inverse, yx. So if I know that 4, 2 is on f, then I know that 2, 4 is on its inverse. And if I know that negative 4, negative 9 is on the inverse, then I know that negative 9, negative 4 is on the original. Okay? So if f of x has xy, then f inverse of x has yx. Okay? And this works both ways. Now, to find the inverse of a function, there are 3 steps. The first thing we do is we change f of x to y. So I'm going to make this y equals 2r minus 4. Then, because this is an inverse, we swap the places of y and our other variables. So make this r equals 2y minus 4. And then we solve for y. So we'd add the 4 divided by 2. So this is my inverse. And all inverse functions are symmetric with each other through the line y equals x. So it doesn't matter what's going on up here. Every function and its inverse are symmetric through the line y equals x. Okay? All right, we talked a little bit about composite functions last time. Let's look at them again. So here if we have h of r and q of r, remember that h open circle q of r is the same as saying h of q of r like that. So in this case, that means that I'm going to do h of r plus 5 over 3. And just like if this were a number, I'm going to replace the r value with what is in here inside these parentheses. So that becomes 3 times, instead of r plus 5 over 3 minus 5. And now this 3 and this 3 cancel, so I'm left with r plus 5 minus 5. Plus 5 and minus 5 cancel, so I'm left with just an r. Okay, let's do it again the other way. Q of h of r would be q, I wrote a g, would be q of 3r minus 5. So I'm going to go to q, and I'm going to replace the r with a 3r minus 5. So 3r minus 5 plus 5 divided by 3. And now this time the plus 5 and minus 5 cancel. The times 3 and divided by 3 cancel. And I'm left with just an r. And if when you do composition like this in both directions, you're left with just your variable, then that means that your functions are inverses. Okay. So we have to be concerned about functions when we're finding the inverse, because only a one-to-one function has an inverse. If a function is not one-to-one, then when you swap x's and y's, you will no longer have a function. So when we're dealing with quadratics, my problem here would be this is the point -2, 4, and this is the point 2, 4, right? So again, when I swap my x's and y's, I would have 4, 2 and 4, -2, and now all of a sudden I'm looking at a graph that's not a function. So what we usually do with quadratics is we say, okay, find the vertex and limit the domain so that we only are looking at the right half of the parabola. Because once we cut the parabola in half, now we're looking at a function as one-to-one. That is one-to-one. And only one-to-one functions have inverses. So if we go back and think about our transformation rules, this would be a parabola that was shifted to the right 3. So its vertex would be here at 0, 3. So if I want to say, okay, I'm not going to use this half of the parabola, then the domain on which this function is one-to-one would be the domain of this half. Ooh, did I say 0, 3? That's 3, 0. And the domain of this half is 3 to infinity. So really, for the domain of a parabola that is one-to-one, you're just going to go from the x value of your vertex and then to the right. And so then the restricted domain of the inverse, well, that would be the restricted range of this function. Because when you have inverse functions like that, the domain of one becomes the range of the other, the range of one becomes the domain of the other. So really then we're just going to ask ourselves, this is the same as asking for the range of Q of t. Why do I keep on saying Q and writing G? So the range of Q of t, if I'm looking at this, is 0 to infinity. Okay. All right. So then let's look at the next one. Again, my 3 steps to finding the inverse are change f of x to y, then swap x and y, and then solve for y. So to solve for y, the first thing that I'm going to do is subtract this 3. Then I'm going to square both sides. I'm going to put this up here. Then let's add the 4. Divided by the 6. And so this is your inverse. Okay. All right. So for this one right here, f inverse of -3. So that means that there's a point on the inverse that is -3. Let's call it A. And they want us to find this A value. Well, that means on the original, there is some point A -3 where these A's are the same. So really, I want to know for what X value does this equal -3? So I'm going to set this equal to -3 and solve. Cross multiply. V plus 2 times 1 is V plus 2. V plus 9 times -3 is -3V minus 27. Add the 3V. Subtract the 2. So that's going to be my value. Okay. So again, they're asking what number would I plug in for V that would give me -3 when they ask you this. So you're just going to set this equal to -3 and solve. And then let's do one more finding the inverse. So we say, change that to Y -5. Swap the C's and the Y's. And then we solve. So just like above, I'm going to put this over 1 and cross multiply. So C times this would be -3CY plus 2C. And then this times 1 is just that. So I need to get everything that has a C together on one side. No, everything that has a Y together on one side and everything that doesn't have a Y together on the other. So let's move this 5 over. We're going to swap the places of this 5 and this -3CY. So I'm going to have 2C plus 5 and then 3Y plus 3CY. Now here I can GCF out my Y because remember the idea here is to solve for Y. And then I'm just going to divide both sides by this. So then Y equals 2C plus 5 over, I'm going to rewrite that as 3C plus 3. And that's going to be my inverse. There is more than one way to solve this type of problem. So if you do it a different way that you like, then do it your way. Okay. But